Okay, we're ready to start. Hi everyone, welcome to our latest webinar. I'm Mados, the Developer Economics Senior Program Manager, and I'd like to introduce you to this new webinar. Focus today will be Industrial IoT, presenting key figures and insight from our report focusing exclusively on this topic. The data is based on our latest Developer Economics survey, which tracked over 4,000 IoT developers. Before we begin, allow me to make a short intro to VisionMobile. We are a leading analyst company in the developer economy, reaching and engaging thousands of developers through our Developer Economics research program. Our research tracks the latest developer trends and helps clients like Google, Intel, Microsoft, and predict where the market is headed next. Our surveys reach developers across the globe and across mobile, IoT, desktop, and cloud. Our speaker today is Stijn Schuermans, Senior Business Analyst at VisionMobile and author of the Industrial IoT report. Stijn is our expert on IoT, having already written numerous reports on the market and has been following this industry since 2012. Stijn's presentation is going to run for around 30 minutes, and then we'll have a brief Q&A session with questions from the audience, so make sure you stick around. Please write your questions on the chat window of the control panel, and we'll address as many as we can during the session and respond to the rest via email. We'll also be recording the webinar and making the recording available to anybody who's joined in. So let's get the ball rolling. Stijn, over to you.
Thank you, Mathis, and also from my side, welcome everyone to this webinar. So as Mathis already mentioned, the insights of this webinar come from our report, The Industrial IoT Landscape, which we published in June of this year. It's based on the 8th wave of developer economics. So this is our main research where we survey developers about their goals, their motivations, their behaviors, and so on. In this particular wave, we surveyed over 4,000 Internet of Things developers, out of which 440 plus industrial IoT developers. So this is the basis for the insights that I will present you today. So in the next 30 minutes or so, I hope I can answer some. I hope I can answer all of these questions. First of all, what do we understand by industrial IoT? Different people might have a different view on that, so I'll try to sketch the space a little bit. We think that software developers and data scientists will play a key role in industry going forward. So why is that? It's maybe an unintuitive statement to start with, so I'll explain that. We'll also look at platforms, developer platforms, so software platforms that are playing in this industrial IoT space. And I'll try to figure out which of those are the most promising going forward, which are the interesting ones to watch going forward. And then in the second half of the webinar, we'll actually switch gears a little bit and look at the developers themselves. Who are they? What kind of profile do they have? And how do they compare to developers in other markets? So let's dig right in with a bit of an introduction on our view on what is the industrial IoT. First of all, when we talk about industry, for the scope of this report and this webinar, we're mainly talking about manufacturing. And the first thing that the Internet of Things, connected hardware, data science brings to this industrial world is basically the next generation of factory automation and optimizing the production line. Some call this the fourth industrial revolution, where the third industrial revolution was factory automation, and then this one moves this factory automation into what's called cyber-physical systems. That means that all the machines inside of this factory line are connected, are generating data, and this data is used to optimize the production process as a whole, and to reduce waste in this production process. So when we say waste, we immediately make this connotation with lean manufacturing. So lean manufacturing plus this new data that comes from the Internet of Things is kind of like lean on steroids. It's the next step, the next generation in factory automation. A related goal to that is to modularize production, making it easier to switch production lines from one product to another, and ultimately arriving at mass customization. So making almost single products one at a time, pushing them through the production line, but in a very smooth way. So this is often listed as a key goal of the industrial Internet of Things. But it's not just about the production process. It's actually about the products themselves as well. Industrial products as well as products that ultimately will arrive at the consumer, like the washing machine that's shown here. So industrial IoT, adding data to machines, adding connectivity to machines, has the opportunity to transform the product and the business around these products as well, in several different ways. One way is to simply make a better product. The connected washing machine is one. Maybe you can make a machine that's remote controlled, whereas before it would require an operator to be on site, to be right next to the machine. A second point of improvement in the product and in the business around these machines is the data that comes from these products as they are being used. Especially in consumer products, this might be the first time ever that a manufacturer has systematic and broad data about how exactly their product is being used, which is quite a big step for some of these manufacturers, quite a change for some of these manufacturers. Even when we talk about more industrial products like the locomotive that's shown here or a jet engine, this data of how the product is used can be used to optimize the product even further. To tweak it in operation, to make sure it runs as smoothly as possible, to do things like predictive maintenance and so on. So this data is looped back not just in product design, but also in product operations, and in marketing, in customer relationship management, and the whole business around this. Finally, you can go even a step further, and this is for some the ultimate goal of the industrial Internet of Things. And the product, especially industrial products, can become actually services. That is, the product is not offered as a product anymore. For example, the locomotive is not offered as a locomotive that is sold to a train company. Instead, GE will sell locomotion. They will sell certain amount of freight transported in a certain time period, for example. This is not a new model. Actually, Rolls-Royce started this back in the 60s. Recently, they celebrated the 50th birthday of their Power by the Hour product line, or service line rather, for their jet engines, where they're basically selling flight time to airline operators. So this is a complete switch in how to think about products, how to think about industrial products. Now these products all of a sudden become services. It's a fundamental shift in the business model around industrial products. So if I can summarize that, we have the two goals in the columns of this little matrix here. On the one hand, we have the efficiency, optimizing the production itself. On the other hand, we have business model transformation, and we have two types of companies. We have companies that build industrial machines, therefore have industrial customers, and we have manufacturers, industrial companies, which build all kinds of devices and want to optimize both their production line and these devices. So in the case of an efficiency goal for an industrial machine maker, this means zero unplanned maintenance, as shown by the guy servicing a jet engine here. It means that their machine can run pretty much forever without any downtime, or at least not any unplanned downtime, which is a big deal for their customers. If they take it to the next step, industrial machine makers, as we said, can make services out of their products. Think of GE again selling locomotion instead of locomotives. For consumer manufacturers, consumer-oriented manufacturers, think about a Bosch, for example. Samsung might be another one. Optimizing the efficiency means having less waste in their production line. It also means having this modular production line where they can easily switch from one product to another, perhaps even arrive at mass customization at a very narrow level. Business model transformation for them means making connected products that changes the relationship they have with the customer. Again, now they have product data which they can feed back into their their product design, but not only the design, also the marketing and customer relationship management around that. So it changes the relationship they have with the customer from a one-off transactional relationship to an ongoing relationship with their customers. There are two big consortia, two big streams of thought around this. The one is Industry 4.0. The other one is the Industrial Internet Consortium. Industry 4.0 started in Germany. It's also heavily backed by the government there. And this one focuses primarily on this modularized production and reducing waste and efficiency. The Industrial Internet Consortium is more USA-based. It's headed by GE and a bunch of other industrial companies. They focus more on this business model idea, the servitization, outcome economy. These are all terms for this idea that the product would now become a service rather than being sold as a product. So that's a main concern for them. And as such, they kind of represent two poles of two lines of thought, two schools of thought around the industrial IoT. Both are valid, and actually the dividing line is not as black and white as it might seem from this. So I want to stress that really what changes versus factory automation and versus what Rolls-Royce was doing back in the 60s is that now there's an abundance of data. Really, the industrial IoT, what it changes in the industrial world is that it's now data first. McKinsey came out earlier this year with a report, and one of the highlights from this report was that in a typical oil rig, which was fitted with 30,000 sensors, only 1% of the data is actually being used. And this mostly for anomaly detection, alarm systems, let's say, and for control of the different parts of this oil rig, not for things like predictive maintenance, not for things like optimizing the entire rig or optimizing the entire process that's going on a rig like that. So this is exactly what is changing. Machines have had control elements for a long time. Now they're getting connected. This by itself technologically is not that big of a change, but the fact that now all this data becomes available is actually a big deal and has a lot of potential in transforming the way that manufacturers and industrial companies actually operate. Now, this data technology doesn't come out of nowhere. It doesn't materialize all of a sudden just there. In fact, it has been under development for quite some time, just not in the industrial world. This is the same big data technology and data crunching technology that was developed for, say, social media or e-commerce in a consumer environment. So another way to put this is that this consumer data technology and this old traditional industrial technology, factory automation and so on, are now converging. Now, as you can imagine, these are two very different kinds of cultures. The data consumer space culture is very fast-moving, iterative design, Silicon Valley type companies, whereas the industrial is more focused on reliability. Is more traditional, let's say, slow-moving but very solid and very systematic. This is a big clash of cultures. Jeff Immelt, the CEO of General Electric, worded it as follows: if you went to bed last night as an industrial company, you're going to wake up this morning as a software and analytics company. In other words, every company, every industrial company will become a software and a data company really overnight from one point to another. This is a big deal. This is not such an easy change, culturally speaking, to overcome. Another major figure in GE, Marco Annunziata, their chief economist, worded as such. He said the internet revolution, which has already transformed the consumer environment, is now beginning to spread to this industrial environment. So he literally says that it's consumer technology that's now kind of invading this industrial environment. Two different cultures coming together, hopefully for the best and creating great new things. But this is a transformation, a change that is not easy, that will take time. Obviously, when we're talking about software and data now coming into this industrial world, it means that software developers and data scientists all of a sudden become very, very relevant in a way that they were not before to this industrial world. In fact, this leads to a big problem. There is a huge shortage of people who are skilled in software, skilled in data in particular, who can make this happen in the industrial world. This is not so easy. One data point I found is that by this year there will be 400,000 data science jobs, but only 140,000 professionals to fill these jobs that are qualified enough to fill these jobs. Okay, that's a quite big gap. Many manufacturers will suffer to actually being able to hire enough data skilled people. We're not just talking about IT professionals. We're not just talking about engineers either in the production line or in the product development team. We're also talking about marketeers, people in sales, service technicians, managers who are skilled enough in data to be able to guide this transformation, especially when we're talking about changing the business model to, for example, a service model, or changing the customer relationship. If you're a consumer device manufacturer from a one-off sale, to really an ongoing customer relationship where you're constantly in contact with your customer. It affects everybody throughout the whole organization, even beyond your organization. In your supply chain, you will need enough people to help you with processing all this data. This is a major challenge for industrial companies going forward. This makes platforms that help developers and that help data scientists so important in this world. They can help to address exactly this challenge. First of all, by providing tooling that makes these data scientists and these software engineers more efficient. Secondly, also to get kind of the right brains at the right place at the right time. In other words, create a connection between the manufacturers on the one hand that need these data scientists and the data scientists that have this knowledge. Connecting these two together will be a very important challenge and assignment for platforms to complete. And indeed, several platforms are rising to the challenge. We see the emergence. So just to summarize this, the opportunity for these platforms is really bridging these two worlds of consumer technology, data technology on the one hand, and industrial technology on the other hand. Bringing the software developers and data scientists that exist in a consumer world into this industrial, making them accessible, let's say, to the industrial world. On the other hand, also guiding those people in how to deal with an industrial world, which has a very different culture than the one they might be used to. This will require a new generation of platforms, and really they do not necessarily have to come from the industrial world. That is to say, whereas the industrial complex at this moment has an existing value chain, an existing value network with an existing set of suppliers, since this is such a transformation, it's not guaranteed that those suppliers, that those technology companies who are already incumbent in this industrial market will actually be the ones to provide these kind of platforms. Still, as I said, there are several ones that are trying, that are moving in, and these companies who are creating platforms for developers, industrial IoT platforms for developers, they come from very different backgrounds. On the one hand, you have a set of industrial companies and suppliers to these industrial companies who are now moving into developers. They're exposing what they already have to developers. So GE with Predix, which is a data platform, is an excellent example of this. It's an industrial company that takes its internal technology and opens it up to third-party developers now. They tend to be mostly focused on this efficiency goal. Remember this scheme that we saw before. They tend to be focused on the production process, on the stuff that they know very well within their own practice as an industrial company. They don't tend to be busy at the moment, or at least not from the platform perspective, with changing the business models to a service line or to an ongoing relationship with customers. Secondly, you have a bunch of enterprise software vendors who have been selling software to enterprises, including manufacturers, for many years, in some cases many decades. Think about IBM, think about SAP, Oracle, Microsoft, these kind of companies. They're also now expanding their platforms, expanding their data platforms to become industrial IoT platforms. They tend to be more full stack, if I can call it that. So they focus across the board, both on industrial machine makers as on manufacturers that make consumer devices, both on the production side, making things more efficient, and on guiding these industrial companies and changing their business models. So they cover the full spectrum of goals and types of companies that are in here. And finally, you have a set of companies who you might not really recognize as industrial companies. Samsung is one, AT&T is one. I have specialists like Xively and ThinkSquare as well. You have even e-commerce companies like Amazon or JD moving into the industrial space. They tend to really be focused on the consumer-oriented manufacturers and on the business model transformation part. You might not really recognize them as industrial companies, but since their customers are industrial companies, we count them in this industrial IoT platform space. So which of these platforms have a good shot of becoming the important platforms for developers and for industrial companies going forward? Well, some of these companies will really focus on the technology. They will focus on getting the hardware there, getting the connectivity there, getting the data processing and the storage there, for developers to create new interesting solutions for the industrial space. That's great. That enables developers to work much faster at less cost, but it only just enables developers to do this. It doesn't actually help developers to become successful commercially, to become successful as developers. Other platforms go a step further. They provide, let's say, an app store for the industry. Just like you have an app store that distributes apps, they will distribute the products, services, algorithms, data solutions that all these third-party independent developers make. They will provide a channel to distribute them to manufacturing industrial customers. In other words, these platforms will empower developers. They will help them to become really successful in this market. So this is a bit abstract, so let me clarify a bit what I mean by distributing products and services. Really, when looking at industrial IoT platforms for developers, see 4 levels of commercialization support or of distribution channel support for developers. The easiest, but in some senses weakest form of this is having partnership programs, partner programs. So as a developer, you would become a partner of the platform vendor. This would give you some kind of exposure. You would be a listed partner. But this exposure is kind of limited, and the barrier to actually become a partner typically is quite high. So now we're talking about platform vendors who have maybe 30, maybe 50, maybe 100 partners. That's not really a very broad spectrum of developers that are offering solutions to the platform vendors' customers, which are the industrial companies. A second level is a certification program. So embed enabled from ARM or Cisco compatible, something like that. This might make it slightly easier because now as a developer, you might be able to get this certification by qualifying to certain requirements without actually having to go through the full kind of custom one-off process of becoming a partner. But still, it's kind of weak. Certified partners are maybe a little bit more trusted, but don't really get that much exposure. typically there's also no easy way to find them. So as a developer, as a vendor, I can market myself as a certified partner, but from the platform owner, it would be difficult to find all the certified partners in some cases. So again, it's kind of it's good, but it's kind of weak. Where it gets interesting is when platform vendors start opening marketplaces. There are two types: component marketplaces and solution marketplaces. In a component marketplace, developers can start sharing among each other modules or pieces of technology that they have developed. This allows a developer by itself to move much faster because he can now mix and match components that others have made. There is more reuse. There is less reinventing the wheel. It also gives a route to market for a developer, because if now I have created a piece of technology, there's a way for me to market that and to actually monetize it through something like a component marketplace. Kind of archetypes of this model are the Amazon Web Services marketplace or the Heroku marketplace. These are really prototypes, if you will, archetypes of what a component marketplace would really look like. The more developers join such a marketplace, the more interesting this marketplace gets to other developers, the more developers will actually join the marketplace. So this creates kind of a network effect where really more developers make the platform itself more valuable. This is an economic dynamic that's actually very, very powerful. And we see that these kind of network effects economics tend to win time after time. Even more powerful, it becomes when a platform vendor has a marketplace that allows developers to sell ready-made solutions, pieces of technology they made, to users. And the users in this case are the industrial companies. So some companies have already started doing this. ThingWorks is a notable example. This is a company acquired by PTC. The Salesforce App Exchange has revolutionized the software as a service space. Really is also an excellent example of what a solution marketplace actually would look like. Here you don't have just network effects between developers. That's to say, the more developers join, the more valuable the platform becomes. But you have two-sided network effects. The more developers join, the more interesting this platform becomes to users, that is manufacturers. The more manufacturers join, this makes it a very attractive, addressable market for developers, so more developers will join. More developers, more manufacturers, more developers, more manufacturers. Again, very powerful proposition for developers and a very powerful economic system. So putting this all together, this is the industrial IoT platform landscape as we see it mid to 2015. Many different companies here. What we see is that really the companies that focus on a platform business as their core business, that sell technology to developers and sell technology to manufacturers, they tend to have the weakest developer proposition as per the previous slide. So they might have some partner programs or something like that. They certainly are unlikely to have any kind of marketplace. Those who take an existing piece of technology, so again, let's use the example of GE, who has developed data technology within the confines of GE and is now opening it up to developers. Again, their developer proposition tends to be quite weak. Sometimes slightly better, so they might have certification programs, they might be a bit more open. None of them have reached the stage where, again, they have a marketplace. Those who do have component marketplaces and solution marketplaces tend to be those who, for a long while already, have an ecosystem of vendors, have an ecosystem of developers. So enterprise software companies like SAP, like Salesforce, like IBM, they have a broad network of independent software vendors for a long time now, and they're now expanding this into the industrial world. They tend to have very strong propositions there. Also, companies coming from the consumer space have these kind of propositions and are now starting to apply that and to help industrial manufacturers produce better products, be more efficient in their operations. So, okay, with this, let's switch gears a little bit, and for the remainder of the webinar, let's look at the developers themselves. What kind of profile do industrial IoT developers have? First of all, there are a lot of them. We estimate that in 2015, there are over 1 million industrial IoT developers already in the world, individuals. These are people that come maybe from factory automation and now add connectivity and data technology to the mix. They might come from machine design. They might come from production engineering. So that is certainly a big group within these industrial IoT developers. But it starts to also see an inflow of people coming from the consumer space who are versed in this data science, who come maybe from social media companies, from e-commerce companies, and who are now starting to apply their skills to the industrial world as well. These people tend to be quite experienced. We see that across different technologies, so whether we're talking about web technology, whether we're talking about mobile technology, software in general, there is a significantly higher number of very experienced people in the industrial IoT than in other areas of IoT. So as indicated with the red circles here. However, the majority of industrial IoT developers have started working in IoT, in Internet of Things, in this connected technology only quite recently. So even though this technology has existed for quite a long time, really now is the time that industrial IoT is emerging, that developers are starting to come in, that software is starting to be applied in a big scale in the industrial world. Another way of looking at the experience and the maturity of developers in this space is by looking at the developer mix across segments. VisionMobile is well known for its developer segmentation model, which is based on the motivations and goals of developers. It's a psychographic model. We have 8 different segments. From hobbyists who are really just having fun, to hunters who are product people, to optimizers who are really engineers working when we're talking about industrial IoT inside of industrial companies, try to get their organization to be more efficient and reduce more costs. So very different spectrum of developers. What we see is that the industrial IoT actually has a very mature professional developer mix. So these are, we see much fewer hobbyists. That's one thing. But actually, the professional segments account for 6 out of every 10 industrial IoT developers, and that's much more than in other areas of IoT. So these kind of segments, they're really the same thing, but from a different perspective. So let's take an example. Say that you have a predictive maintenance solution, data crunching in order to do predictive maintenance. If, as a developer, you have productized this and you're selling this to manufacturers, you would be a hunter. If you're hired to develop such a solution for a manufacturing company as a technology consultant, you would be a gun for hire. If you have a maintenance solution and now you're starting to use data and expanding your solution in order to become an IoT solution, you would be a product extender. If you're doing the same job within a manufacturing organization and doing it in-house, you would be an optimizer. So these are really different professional segments, and together they account for many more, a much higher percentage of industrial IoT developers than in other areas. In fact, industrial IoT, out of all the different verticals in IoT that we're investigating, would be the most mature, the most professional segment of them all. So it's not just the average; that's much higher. Industrial IoT would be right at the top in terms of developer maturity. When we look at regional distribution of developers, so where are those industrial IoT developers? North America, Western Europe, certainly. Western Europe seems to be a hotspot. That doesn't need to necessarily surprise, given that the main industrial center in Europe, which is Germany, is also very actively pushing for this industrial IoT concept. In fact, Industry 4.0 is the consortium or the initiative that's very active there. So this is not very surprising to see a higher number of industrial IoT developers there. East Asia, meaning China, seems to be lagging behind a bit in terms of industrial IoT developers relative to other types of IoT developers. This might surprise a little bit more, since China obviously is a big manufacturing center in the world. So still, the expertise doesn't seem to be there quite as much. Still, 19% of industrial IoT developers are in East Asia. That's a very significant number of developers right there. It's important to realize that not all of these developers and not all of these companies are actually very big companies. Maybe when thinking about industrial IoT or about industry in general, we have in mind big manufacturers, you know, the Bosches and Siemenses of this world, or big vendors, the IBMs and the SAPs of this world. Developers are actually much more distributed. We do see a much bigger percentage of big companies in industrial IoT versus other areas of IoT. However, the majority are still small companies with under 50 people in the company. So it's not just the big boys, it's smaller developers as well. This is also kind of mirrored or matched by a lot of small manufacturing companies out there. So that's the customers of these developers. Over 2 million manufacturing, small manufacturing companies with under 250 employees in Europe alone. So this is a very significant market for these developers. What this really means is that there's a long tail opportunity somehow. Yes, there will be the big boys, the GEs and the SAPs and the Oracles and so on, catering to big manufacturers. But there are both small developers, small ISVs on the one hand, and small manufacturers, that if you can connect those two together, there's actually a big opportunity to create a platform that connects them, that creates a marketplace that allows them to exchange technology in this way. Big opportunity there that should not be overlooked. This is actually quite a big part of the market. We asked industrial IoT developers what is their biggest challenge. The #1 challenge is immature platforms, tools, and standards. So immature platforms, here we are. These platforms really are important for developers. By the way, the #2 challenge is a lack of hardware development knowledge, but this really is a challenge mostly for inexperienced Internet of Things developers. As experience rises, this challenge kind of drops. So we can expect that this will not be a major issue going forward. This is kind of a temporary thing, whereas experience grows, this challenge again will diminish. So really the #1 challenge is these platforms. For now, a big part of the challenge with these platforms is how high friction they are, along, of course, with all the traditional requirements that you might have of a platform in terms of scalability and reliability and so on. Given the experience from other areas where we have these kind of developer platforms, we know that reach and monetization and these marketplaces really will become the top reason to select an industrial IoT platform in the future. And one indication that we have of that is when we asked industrial IoT developers which general purpose platforms they're actually using, the #1 and the #2 are actually e-commerce companies. This is very surprising. So the industrial specialists, if you will, like PTC and more down GE Predix, really score much lower than that. Why is that? Because Amazon, JD are companies that have had developer ecosystems for a long time, that do offer these kind of marketplaces. So we really see that this matters to industrial IoT developers as well. This is a conclusion we're drawing here for industrial IoT developers, but we're seeing the same thing over and over again in every different area of the Internet of Things, as well as in mobile and other areas in which developers are active, cloud development, and so on. So this is really a conclusion that holds also for industrial IoT developers, but not just for them. So with this, let me wrap it up here and summarize some of the key insights. First of all, every industrial company is going to become a software and data company quite fast. This means that a whole new set of skills and ideas need to come into this industrial space, a big clash of cultures, and also a big gap in terms of skills that needs to be filled within this industrial world. A lot of this technology and many of developers will actually come from consumer markets, as well, perhaps some of the platform vendors. So certainly there is no guarantee that the current industrial technology vendors will become the most important platform vendors going forward. Really, we're seeing a change of generation that goes along with this fundamental switch to becoming a software data kind of industry. The winners looking forward in terms of industrial IoT platforms for developers, what will they look like? They certainly must bring more than just technology. They must actually help developers to commercialize their ideas, help them, give them a channel in order to reach their manufacturing customers. Component marketplaces in this are kind of baseline. Solution marketplaces are where the real powerful stuff is. And indeed, we see some platforms, IBM, SAP, Salesforce, and so on, who are building these kind of marketplaces as we speak. Companies with existing developer ecosystems certainly are ahead. They're in pole position in terms of creating the strongest propositions for developers. And we found that Amazon and JD, two e-commerce companies, are really leaders among general purpose IoT platforms, among industrial IoT developers. Finally, there are a lot of industrial IoT developers already, over 1 million, according to our estimate. They're fairly mature, they're experienced, a lot of them are in professional segments, but they have a challenge, and that challenge is finding mature platforms. And finally, we mentioned that there's a long tail opportunity connecting small companies, both small developers with small manufacturers. So with this, let's have some questions. Let's open it up for questions. Matus, over to you.
Thank you, Stijn. So we have already a couple of questions. Some of them you can see on the chat window. So let's start with this. Industrial companies are a very different environment from consumer markets like wearables, and they have different requirements in terms of reliability, security, procurement, etc. So how can an app store model work there? Stijn, are you with us?
I was muted indeed. Thank you, Matus. So really, there might be some skepticism that these models which come from the software world, which come from the Silicon Valley type of world, might be applicable to this very different context of industrial companies that are out there. But I would argue some reasons why indeed that is exactly what will happen. First of all, manufacturers do have suppliers of all kinds, so we can assume that they will have suppliers for their software needs, for their data algorithm needs as well, right? Then there are two ways to actually organize this. The one is a traditional vendor model, where you go out there in the big world and you try to find a supplier, you try to find a vendor, or if you're the supplier, you're trying to find customers. The other model is you have a marketplace. You have a centralized place where these two things, where the software supplier on the one hand and the manufacturing customer on the other hand come together. So this tends to be a very powerful model. We see this over and over and over again, exactly because of these network effects. The more solutions are offered on this platform, the more interesting it becomes for manufacturers to also join the platform and vice versa. Now, the platform owner in this has a very important task, has a very important responsibility, which is to curate these solutions, to make sure that indeed these vendors can be trusted, that they are reliable, that they are secure, that they have the right domain knowledge, and so on and so forth. So this kind of curation and quality guarding is a key aspect of any kind of platform or marketplace that does this. In the App Store, as we understand it from mobile devices and so on, this is not that important. It doesn't really matter that much if there's like a lower quality app out there. We see that iOS, for example, does a more strict job at this than Android, so you can play a bit with this. It's obvious that for marketplaces that play in an industrial space, this will be more important. There will be more strict curation, more strict quality guarding. But the model as it stands and the economic power of this model stands. It's still valid. It doesn't invalidate the model. The fact that we now would have to have a bit stronger curation. Now, the skepticism by itself is kind of really this clash of cultures that we're talking about. I'm not saying that this will be easy, that this will be obvious for industrial platform vendors to do this kind of work, to do this kind of curation, to establish this kind of marketplace. But certainly it's not impossible either. We've seen Salesforce doing it in enterprise software, and others, many software as a service companies are doing this in enterprise software. We're convinced actually that this can happen in industrial world just the same. And to add, those who do manage to build that will really get a competitive advantage. Look at how Salesforce revolutionized the customer relationship management space, or the enterprise software space with exactly this model. So yeah, skepticism is maybe warranted to some extent. This will not be an easy assignment, but don't discount the model because it's very, very powerful.
Thank you, Stijn. We have a couple of questions related to platforms. So how can industrial IoT platforms help address the skill shortage that you mentioned?
So I kind of mentioned that in passing, that really there is a skill shortage. This actually is quite well understood and quite well known, and a shared insight among many different players and thought leaders within industrial IoT. So this is kind of established. I said that platforms can really help to address this skill shortage, but I didn't maybe really explain very well how. So I think that there are several ways in which platforms and marketplaces can help to do that. The first is that by providing better tools to developers, the speed at which developers create new solutions increases. This means that they can just develop more solutions, which means that the capacity of this developer population as a whole actually increases. So that's one way that skills shortage can be helped by platforms. Another way is that it improves the reuse of solutions across these manufacturers. So this I kind of mentioned in the context of component marketplaces. Developers won't have to reinvent the wheel over and over and over again. They can take components, or they can take entire solutions that were developed in a slightly different context, maybe tweak them a little bit, and reuse them again. This means that much fewer people are needed to actually develop the solution, because you don't have to develop it from scratch again. So that's another way that a marketplace might really help to address this skills issue. And thirdly, really, there is this issue of kind of liquidity. It's getting the right people in the right place at the right time. So if you have to hire someone in order to do a specific job, this is a quite slow process. And you're stuck with that person for a while. Hiring and firing very fast is typically not really accepted. So in an environment where technology moves faster and faster and faster, the ability to use a marketplace to find a developer really is important in order to address challenges quite fast. So you have access basically to this global pool of developers who can all get solutions to you through this marketplace. You don't actually have to hire them or get them in-house or get them in a long-term contract or anything like that, which would be the case if you don't have this kind of platform, you don't have this kind of marketplace.
Thank you. In terms of the numbers mentioned earlier, it seems that Asia is lagging behind. Why is that?
So we haven't really dug very deep in this. It might be that they're actually not lagging behind that much. Again, the number for South Asia was 17%, if I recall correctly. The number for East Asia is 19% of the Industrial IoT developer population. Those are indeed not low numbers. So there are a lot of engineers in those areas working on Industrial IoT solutions. They're lagging behind relative to other IoT developers. Another way to put it is that other IoT developers might be ahead of Industrial IoT developers. And indeed, we see, for example, in areas like wearables, that developers that are based in Asia are actually far ahead. They're experimenting very widely with wearables in Asia. There's a very active area of development. It might be more attractive to many developers in those regions at the moment than the industrial spaces. This doesn't necessarily mean that Asia as a or individual countries within Asia will start lagging behind on the technology. That's not necessarily the case.
Okay, I think we have time for one last question. How do you explain the discrepancy between the maturity of this vertical and the fact that it's so early stage?
Apologies. So when we say that this vertical is quite mature, we're really talking about the mix of developer segments, and I remind you that these developer segments indicate the goals and the motivations that developers have for actually being in this space. So this doesn't necessarily need to surprise, because when we're talking about the industrial complex or industrial companies, really this is a 2 centuries old industry, if you will. So sure, they have established market practices. They have certain things that are acceptable to them in terms of the seriousness of developers. And even intuitively, you can understand that that hobbyists don't really have a place in a very industrial world. On the other hand, when we're talking about early stage, we're talking about the fact that really there's a big switch from a traditional factory automation and industrial technology to now being much more software-centric, much more data-centric. And we're talking as a consequence of that, a lot of developers who are now for the first time starting to get into Internet of Things technology, or maybe who come from a different kind of background, from a consumer background, and are moving into the industrial world. So that's what's new about it. So really, this discrepancy is not really a discrepancy. Yes, you need to have a certain professional profile if you want to play in this industrial space. But that doesn't mean that you can't be new to IoT or you can't be new to data science, or that the platform itself cannot be new or cannot be emergent as we speak.
Thank you, Stijn. There are a few other interesting questions, but unfortunately we're out of time. We've recorded them and we'll be getting back to you via email. So with this, we're concluding today's webinar. Thank you all for sticking around. Hope that you find today's webinar interesting, and don't hesitate to get in touch with us if you have any other questions. You can reach me at matos@visionmobile.com or Stijn at visionmobile.com. That's STIJN. Don't forget to check out the dedicated Industrial IoT Landscape report, and see you all next time. Goodbye.